Hello students, welcome to another video. In this video we will be solving Pure Mathematics Paper 1 from February-March 2017, Variant 2. Question number 1. Find the set of values of k for which the equation 2x squared plus 3kx plus k is equals to 0 has distinct real roots. So this is the equation. So if you compare this equation with ax squared plus bx plus c, a will be 2, b will be 3k, and c will be k. So when the equation has distinct real roots, the discriminant b squared minus 4ac must be greater than 0. That means 3k whole square minus 4 times 2 times k is greater than 0. Simplifying this, we get 9k square minus 8k greater than 0. If we take k common, we will get 9k minus 8 greater than 0. So k is equals to 0 and k is equal to 8 over 9. These are the critical values. So since this is a positive quadratic equation, the number line will have 0 and 8 over 9 over here, and the curve will look like this. So in order to get the set of values which is greater than 0, k must be less than 0 and k must be greater than 8 over 9. Question number 2. In the expansion of 1 over ax plus 2ax squared whole to the power 5, the coefficient of x is 5. We need to find the value of the constant a. So the expansion will have 5cr 1 by a to ax to the power 5 minus r, then 2ax squared to the power r. Now let's isolate the x terms and we will get x to the power minus 5 minus r because x was in the denominator. If we bring it to the numerator, it will have negative power, and x to the power 2 times r, which is 2r. So this must be equal to x to the power 1 because the question says the coefficient of x is 5. So we are looking for the value of r for which we will get the coefficient of x, and coefficient of x basically means x having the power of 1, and that will have 5 as the coefficient. So simplifying this, we get x to the power minus 5 plus r, and since we have multiplication, that means this power will get added with this, so it will be plus 2r equals to x to the power 1. Simplifying it further, we get 3r minus 5 is equals to x to the power 1. So with the help of equality rule, we get 3r minus 5 is equals to 1. So r will be equals to 2. Now we can substitute this value of r into this equation and we will get 5c2 1 by ax to the power 3 times 2ax squared to the power 2. And this is equals to 5x because it was stated in the question that the coefficient of x is 5. So 5c2 is 10 and this will become 1 over a cube x cube times 2 square is 4, a square is a square, and x to the power 2 times 2 will be x to the power 4. So simplifying this, we get 40 by a x. So as you can see, with the help of the value of r, which is 2, we are getting the coefficient of x. So this must be equal to 5x. Now we can say that 40 over a is equals to 5. Therefore, a is equals to 8. Question number 3. The diagram shows a water container in the form of an inverted pyramid, which is such that when the height of the water level is h centimeter, the surface of the water is a square of side half h centimeter. So this is a square. It is also provided that the volume of a pyramid having a base area A and vertical height h is 1/3 of AH. Now, as we know that this is a square, that means the base area of this, which is inverted of course, so it will be half h whole square. Since this is a square, the area will be half h whole square. So volume will be 1/3 of half h whole square times h with the help of this formula. Simplifying this, we get volume is equals to 1/3 of h square over 4 times h, which will give us h cube over 12. In the second part of the question, it says water is steadily dripping into the container at a constant rate of 20 centimeter cube per minute. We need to find the rate in centimeter per minute at which the water level is rising when the height of the water is 10 centimeter. So what we are provided with is that water is dripping at a constant rate of 20 centimeter cube. That means the volume, since centimeter cube is the volume, they're talking about the volume. So dV by dt is 20, and we already found in the first part of the question that V is equals to h cube over 12. And it is also provided that we need to find the rate at which the water level is rising when the height is 10 centimeter. So h must be 10. dV by dh, if I differentiate this equation, I get 3h square over 12, which is h square over 4. So in order to get dh by dt, we can use the chain rule, and we will get dh by dv into dv by dt. So when h is equals to 10, dh by dt will be equal to 4 over 8 square. The reason why it is 4 over 8 square, because we found dv by dh, which is 8 square over 4. So dh by dv will be the reciprocal of this, which is 4 over 8 square. And h is 10, so it will be 10 square. And dv by dt is 20. So simplifying this, we get dh by dt is equals to 0.8. Question number 4. In the diagram, AB is equals to AC is equals to 8. So AB equals to AC equals to 8 centimeter. And the angle CAB, which is this angle, is 2 pi by 7 radians. The circular arc BC has center A. The circular arc CD has center B. And ABD is a straight line. So this is a straight line. We need to show that angle CBD is 9 pi by 14 radians. So we need to find this angle CBD. So first of all, what we did here, we know that triangle ABC is isosceles because these two sides are the same. That means angle ABC and angle ACB must be equal because they are the opposite angles of the equal sides. So considering angle ABC x, we can say that x plus 2 pi by 7 must be equals to 180. And 180 degree in terms of radians is pi. So this will be 2x plus 2 pi by 7 equals to pi. Therefore, 2x is equals to pi minus 2 pi by 7, and that will give us 2x is equals to 5 pi by 7. So x is 5 pi by 14. So we managed to find the value of the angle CBA. Therefore, CBD must be pi minus 5 pi by 14 because angle in a straight line is 180, which is pi. So 180 or pi minus this angle should be giving us the angle CBD. So that will be 9 pi by 14. In the second part of the question, we need to find the perimeter of the shaded region. So let's look into the diagram again. So this is the shaded region and we are required to find the perimeter of the shaded region. So we need to find the line DB, the arc BC and the arc DC. So in triangle ABC, CB square, we are using the cosine formula to find the length of CB, which is this. We are trying to find the straight line CB. So CB square will be 8 square plus 8 square minus 2 times 8 cos 2 pi by 7. The reason why we are trying to find CB is because, as it was stated in the question, that for the arc DC, B is the center. That means if B is the center, BC and BD are the radius of this sector. So if I manage to find the radius, then I can also find the arc length, because we already know the angle CBD. And the cosine rule can be used because we know these two sides of the triangle ABC. We also know the angle. All we need to do is find CB. So solving this, we get CB is equals to 6.94. Therefore, the arc length DC will be 6.942 times the angle. So that will be 9 pi by 14. And that gives us 14.0203. Now the arc length BC will be, the formula is again r theta. So the r is, or the radius is 8 centimeter. The radius is 8 centimeter and the angle is 2 pi by 7. So I'm trying to find the arc BC with the help of this radius and the angle. And that gives us 7.1808. And we know that DB is equals to CB because they are the radius of the sector DBC. So DB must be equal to CB. So the required perimeter will be 14.0203, which is this, plus 7.1808 plus 6.942, and that will be 28.1. Question number 5. The diagram shows the graphs y equals to 10x and y equals to cos x within the limits 0 and pi. The graphs intersect at points A and B. Find by calculation the x coordinate of A. So y is equals to 10x and y is equals to cos x. So if I equate these two equations, y equals to y, I get 10x equals to cos x. Or I can say sin x by cos x equals to cos x. If I cross multiply, I get sin x equals to cos square x. I can manipulate cos square x by writing 1 minus sin square x. So if I bring all these to the left hand side, I get sin square x plus sin x minus 1 equals to 0. So then I can consider sin x to be a, and we can use the help of quadratic equation to find the value of sin x. So I can rewrite this equation as a square plus a minus 1 is equals to 0. So a will be minus 1 plus minus square root of 1 square minus 4 times 1 times negative 1 over 2a, which is 1. So a will be minus 1 plus minus square root of 5 by 2. That will give us a is 0.618 and a is negative 1.618, which means sin x is 0.618 and sin x is negative 0.1618. The basic angle should be sine inverse of 0.618 and the basic angle should be sine inverse of 1.618. And we know that the maximum and minimum limits of default sin x is 1 and minus 1. So this will have no solutions. And the basic angle of this one will be 0.6662. So the x coordinate of A must be 0.66 to 3 significant figures. In the second part of the question, we need to find by calculation that the coordinates of B. So Previously, we found that sine x is equals to 0.618. That means the basic angle came down to 0.6662. So the x coordinate of B, which lies on the second quadrant, will be pi minus the basic angle, which gives us 2.475. And in three significant figures, it should be 2.48. Question number 6 is not in the syllabus at the moment. Question number 7. The function f is defined for x is greater or equal to 0 by the function f of x is equals to 4x plus 1 to the power 3 by 2. We need to find f prime x and f double prime x. That means we have to find the first derivative and the second derivative of this function. So this will become 3 over 2 times 1 is 3 over 2. Then 4x plus 1 to the power 3 by 2 minus 1 gives us half. And if we differentiate then the inside, we get 4. Simplifying this, we get 6 times 4x plus 1 to the power half. If we differentiate this equation again to find the second derivative, we get half times 6 is 3. Then 4x plus 1 to the power half minus 1 is negative half. And again, if we differentiate inside, we get 4. So simplifying this, we will get 12 times 4x plus 1 to the power negative half. In the second part of the question, it says that the first, second, and third terms of a geometric progression are respectively f of 2, f prime of 2, and k f double prime of 2. We need to find the value of the constant k. So let's first use these equations and substitute the value of x as 2 and find their respective values. So f of 2 must be 4 times 2 is 8. So it will be 8 plus 1 to the power 3 by 2, which is basically 9 to the power 3 by 2. And we know that 9 is a square number. So that can also be written as 3 square to the power 3 by 2. Simplifying that, we get 3 cube, which is 27. And f prime of 2 must be 6 times 4 to the 8 plus 1. So it will be 8 plus 1 over here to the power half. 8 plus 1 is 9. 9 can be written as 3 square. So 2 will cancel and we will have just 3. So 6 times 3 will be 18. And k f double prime of 2 will be equal to k times 12. Again 4 to the 8, so it will be 8 plus 1 to the power negative half, which will be 12k times, this will become 9 to the power negative half, or we can say 1 by 9 to the power half, which is 1 by 3. So simplifying this, we get 4k. Now since they have stated that this is a geometric progression, that means the first term, let's say it is 27, then it is 18, and then it is 4k. So we know that the common ratio of the geometric progression can be found by dividing next term by the previous term. So 4k, which is the third term, divided by the second term, which is 18, must be equal to the second term divided by the first term. So 4k by 18 is equals to 18 over 27. If I simplify this and make k the subject, I get 18 times 18 over 4 times 27. And that will give us the value of k, which is 3. Question number 8. The functions f and g are defined for x is greater or equal to 0 by f of x is 2x squared plus 3 and g of x is 3x plus 2. We need to show that gf of x is equal to 6x squared plus 11. And we need to obtain an unsimplified expression for fg of x. So this is f of x and this is g of x. So gf of x must be, we need to substitute f of x into g of x. So that will give us 2x squared plus 3 within brackets plus 2. Then we get 6x squared plus 9 plus 2, which is 6x squared plus 11. And that is what we had to show. Now, f g of x will be, g of x will get substituted into x squared. So that will become 3x plus 2 whole square plus 3. And we don't have to proceed any further because they have asked for the unsimplified expression. In the second part of the question, we need to find an expression for fg inverse of x, and we need to determine the domain of fg inverse. So fg of x we previously found is 3x plus 2 whole square plus 3. Let's consider y to be fg of x, and then we can make 3x plus 2 whole square the subject of the equation, and we will get y minus 3 over 2. Now if I take away the square by square rooting both sides, I get 3x plus 2 is equals to plus minus square root of y minus 3 by 2. That means 3x is equals to negative 2 plus minus square root of y minus 3 by 2. So x will be minus 2 over 3 plus minus 1/3 of square root of y minus 3 by 2. Fg inverse of y must be x, so Fg inverse of y should be equal to this equation. Therefore, Fg inverse of x should be minus 2 over 3 plus 1/3 square root of x minus 3 by 2. Now, in order to find the domain of Fg inverse of x, we know that domain of Fg inverse of x is equals to the range of Fg of x. So let's first find this. F of x is equals to 2x squared plus 3 and g of x is 3x plus 2 for x is greater or equal to 0. So when x is equals to 0, g of x is just 2 because 3 times 0 is 0 plus 2 will give us just 2. So when g of x is equals to 2, this is the range of g of x. That means this is the output of g of x, and we know that the output of g of x will become the input of f of x when it's a composite function. So when x is equals to 2, we need to substitute this into the equation of f of x. We need to substitute this into the equation of fg of x. And fg of x should be 2 within brackets 2 square plus 3. So there was an error in the writing of the function, which I have just fixed. So as I was saying that g of x is equals to 2 when x is equals to 0. And this is the output of the function g. So this will become the input for f of x. So when x is equals to 2, f of x is 2 within brackets 2 square plus 3. So f of x will be 11. And this is the output of the function f of x, which is also the range of the composite function fg of x. So that means the domain of fg inverse of x is x greater or equal to 11. In the third part of the question, we need to solve the equation gf of 2x equals to fg of x. So these were the functions. F of x is 2x squared plus 3 and g of x is 3x plus 2. So fg of x must be, we need to substitute this equation into f of x and we get 3x plus 2 whole square plus 3. So that will become, okay, and gf of x will be 3 within brackets 2x squared plus 3 plus 2. So now we are substituting 2x squared plus 3 into this equation. So this is the function fg of x and this is the function gf of x. So gf of 2x should be 3 within brackets 2, again within brackets 2x whole square plus 3 bracket close plus 2. So we are replacing x with 2x. So gf of 2x must be 3, and if we simplify this, we get 8x plus 3 plus 2. As it is stated in the question, gf of 2x is equals to fg of x. So gf of 2x is 3 within brackets 8x squared plus 3 plus 2 equal to 3x plus 2 whole square plus 3. If we expand the brackets, we get 24x squared plus 9 plus 2 equals to 9x squared plus 12x plus 4 plus 3. Simplifying this, we get 24x squared plus 11 equals to 18x squared plus 24x plus 8 plus 3. Then we can cancel out positive 11 from both sides, and we are left with 24x squared minus 18x squared minus 24x equals to 0. So that will give us 24x squared minus 18x squared is 6x squared and negative 24x. We can take 6x common and we get x minus 4 within brackets. Therefore, 6x is equals to 0, which means x is equals to 0, and x minus 4 is equals to 0, which is x is equals to 4. Question number 9. The point A, 2, 2 lies on the curve y is equals to x squared minus 2x plus 2. We need to find the equation of the tangent to the curve at A. So y is equals to x squared minus 2x plus 2. So dy by dx should be 2x minus 2. So when x is equals to 2, because that is the x coordinate for the point A, the gradient, which is dy by dx, must be 2 times 2 minus 2, and that will give us 2. So we know the gradient and we have a coordinate. So we can easily find the equation of the tangent, and that will be y minus y1 over equals to mx minus x1. So y minus 2 is equals to 2x minus 4. Therefore, y is equals to 2x minus 2. And this is the equation of the tangent. In the second part of the question, the normal to the curve at A intersects the curve again at B. We need to find the coordinates of B. So equation of the normal at A, the coordinate still remains, of course, 2, 2, but the gradient of the normal will become minus 1 over the gradient of the tangent, which was 2. So this becomes minus half. So the equation of the normal must be again y minus y1 equals to mx minus x1, but here the gradient is minus 1 by 2. Simplifying this, by cross multiplying 2 with y minus 2, we get 2y minus 4, and minus 1 times x is minus x, minus minus plus 2. So that gives us 2y plus x is equals to 6. So y is equals to half of 6 minus x. For the curve, y is equals to x squared minus 2x plus 2. Now since this normal, which is this, the equation of the normal is this, will meet again the curve at B. That means we need to equate these two equations. So simplifying this by multiplying 2 with this whole equation, we get 2x squared minus 4x plus 4 is equals to 6 minus x. Then we can simplify further by writing 2x squared minus 3x minus 2 is equals to 0, which gives us 2x squared minus 4x plus 6 minus 2 is equals to 0. So here we are doing middle term break. If we take then 2x common, we get x minus 2 plus 1, and again we get x minus 2. Therefore, the factors are 2x plus 1 and x minus 2. Which means x is equals to negative half and x is equals to positive 2. So when x is negative half, if we substitute this value of x into any equation, whether it be the normal or the curve, still we will get the same y value for the coordinate B. So y is equal to half of 6 minus half. This is the equation of the normal, and we can find the value of y easily by substituting the value of x into this equation. And that gives us y is equals to 13 over 4. So the coordinate B must be minus half and 13 by 4. The reason why we are not dealing with x equals to 2, because this was the point A of which the x coordinate was 2. So this x coordinate belongs to the point A, and this must be then the coordinate x coordinate of the point B. In the third part of the question, the tangents at A and B intersect each other at C. We need to find the coordinates of C. Now they're talking about the tangents again. So let's find the gradient when x is negative half. So dy by dx is 2x minus 2, which we found previously. As you can see, when we differentiated this equation y is equals to x square minus 2x plus 2, we got the equation of the gradient. So 2 times minus half minus 2 will give us minus 3, and this is the gradient when there is a tangent at the point B. So equation of the tangent at B, and we already know the coordinates of B. So it will be y minus y1 equals mx minus x1. So that will be y minus 13 over 4 equals minus 3, x minus minus half is positive half. Simplifying this, we get 4y minus 13 is equal to minus 12 within brackets x plus half. So we cross multiplied 4 with minus 3, and while doing that we also made sure of multiplying 4 with y because there is no 4 in the denominator of y. So 4y minus 13 is equals to negative 12x minus 6. So 4y plus 2x is equals to 7. Therefore y is equals to 1/4 of 7 minus 12x. That was the equation for the tangent at B, and the equation of the tangent at A is y is equals to 2x minus 2, which we already found in the previous part of the question. So in order to find C, since the question says that the tangents at A and B will intersect at C, that means we need to equate the equations of these two tangents. So that will be 2x minus 2 is equal to 1/4 of 7 minus 12x. Cross multiplying this, we get 8x minus 8 equals to 7 minus 12x, which is 20x is equals to 15. Therefore x will be 3 over 4. So that is the x coordinate of the point C. Now to find the y coordinate, we can simply substitute the x value into any of the equations of the tangents. So y is equals to 2 times 3 over 4 minus 2, that gives us negative half. So the coordinate of C must be 3 over 4 and minus half. Question number 10. The diagram shows the curve y equals to f of x defined for x greater than 0. The curve has a minimum point at A and crosses the x-axis at B and C. It is given that dy by dx is equals to 2x minus 2 over x cubed, and that the curve passes through the point 4 and 189 over 16. We need to find the x coordinate of A. So since dy by dx is equals to 2x minus 2 over x cubed, we know that since this is the minimum point, the gradient over here will be 0, which means dy by dx is equals to 0. So we can substitute this value to this equation and we get 2x minus 2 over x cubed equals to 0. If I cross multiply x cubed with 0, it becomes 0, and x cubed times 2x is 2x to the power 4. So 2x to the power 4 minus 2 is equals to 0. Or we can say 2x to the power 4 is equals to 2. Therefore, x to the power 4 is equals to 1, which means x is 1. And that is the x coordinate for the point A. In the second part of the question, we need to find f of x. So dy by dx is 2x minus 2x to the power minus 3. So y should be integrating the value of minus 2x to the power minus 3. So integrating 2x, we get x to the power 2 plus this will become the power minus 3 and plus 1 gives us minus 2. So minus 2 divided by minus 2 will give us positive 1 and x to the power minus 2 plus c. When x equals to 4, y is equals to 189 over 16. So we can substitute these two values to find c. So that means 189 over 16 is equals to 4 square plus x to the power minus 2 can be written as 1 over x square. That means 1 over 4 square plus c. So 189 over 16 is equals to 16 plus 1 over 16 plus c. That means c is equals to minus 17 over 4. So the equation must be y is equals to x square plus x to the power minus 2 minus 17 over 4. And since y is equals to f of x, we can say f of x is equals to x square plus 1 over x square minus 17 by 4. In the third part of the question, we need to find the x coordinates of b and c. Let's look into the diagram again. So this was the diagram and we are now required to find b and c, which lies on the x-axis. So at x-axis, y is 0. That means f of x is equals to 0. So x square plus 1 over x square minus 17 by 4 must be equal to 0. Now if I multiply x square on both sides of the equation, I get x to the power 4 plus 1 minus 17x square by 4. Now if I multiply 4 to both sides of the equation, I get 4x to the power 4 plus 4 minus 17x square equals to 0. So I can rewrite this as 4x to the power 4 minus 17x square plus 4 equals to 0. And I can clearly see that I can form a quadratic equation by manipulating x to the power 4. So if I consider a to be x square, I can say that 4a square. So a square will be x to the power 4 and a is just x square. So 4a square minus 17a plus 4 is equals to 0. I can do the middle term break and I get 4a square minus 16a minus a plus 4 equals to 0. Then I can take 4a common and I get a minus 4 within brackets. And if I take minus 1 common, I get a minus 4 again within brackets. So the factors are 4a minus 1 and a minus 4 equals to 0, which means a is 1 over 4 and a is positive 4. That means that x square is 1 over 4 and x square is 4. If I square root both sides, I get x is equals to positive half and x is positive 2. Since the point B comes before the point C, that means the x coordinate of B must be half and the x coordinate of C is positive 2. In the fourth part of the question, we need to find, showing all necessary working, the area of the shaded region. So in order to find the area of the shaded region, we need to integrate this equation. So, and we know the x coordinates, which are the limits for the shaded region, and that was 2.5, which are the x coordinates of B and C. So if we integrate this equation, we get x to the power 2 will become 2 plus 1, 3 and 1 by 3 minus 2 plus 1 is minus 1. So 1 by minus 1 will be minus 1 over x. And this will become minus 17x by 4. If I substitute these two limits into the equation and subtract them, I get minus 19 over 3 plus 49 over 12. And also we can clearly see that the shaded region lies below the x-axis. That means we will be getting a negative area. And since we know that area cannot be negative, we have to use the modulus sign so that we get the positive area. So Minus 19 over 3 plus 49 over 12 gives us negative 9 over 4. So with the help of the modulus, we get the area, which is positive 9 over 4. And that will be all for now. I will see you in the next video.